Okay, in this question for logs, we have some logs that need to be simplified. So what I want to do is try and write it with a common log on both sides. So I'm going to simplify these. So any number that is in front, I'm going to bring it up. Ones that are subtracted, I am going to divide. Before I get too carried away, let's list our restrictions on the side. So in my first one, can't take the log of a negative. In my next one, can't take the log of a negative, which means x has to be greater than -2. And in the last one, 2x minus 3 has to be greater than 0, which means that 2x is greater than 3, x is greater than 3/2. So I want to find one restriction that covers all of them. So I always go with the biggest restriction. If x is greater than 3/2, it will already be greater than 0, and it will be greater than -2. So just try and simplify it into one restriction. Okay, so numbers up front go up top to be exponents. Okay, and notice there is no base, so it's a common base of 10. Logs that are subtracted can be combined through division of the arguments equals to log of 2x minus 3. So since we have log on both sides and since they are equal on both sides, the only way that that could be possible is if the arguments themselves were equal. So we have this nice rational equation. So now we're back to 20-1, solving rational equations. So what I'm going to do to solve this is I am going to get rid of my denominator, get rid of my fraction. I'm going to multiply this side by x plus 2. And to be fair, I multiply this side also by x plus 2. So that's gone. So I'm left with x squared equals distributive property on the other side. And then just tidy it up. As I tidy it up, because I have a quadratic, I know I solve quadratics by setting them to 0, so I'll subtract x squared from both sides. So x squared plus x minus 6. I have a quadratic, so I always have to factor when I have a quadratic if possible. If not, I'll go to the quadratic formula. So two numbers that multiply to -6 and add to +1, so that would be +3 and -2. So one solution, x is -3. The other solution is +2. So we check it in the restrictions first. So when I get to -3, I check it up here and I see, uh-oh, that is not greater than 3/2. So what I can say is, I can say this is not a solution. You could say you can't have a negative argument. I think the easiest way of saying that is just extraneous. Okay, so then we have a potential solution of x equal to 2. But the only way I know for sure that it's a solution is by plugging it into the original. Okay, so now in this case here, because I have quite a big question, I'm going to use y1, y2 intersect. The other questions, it was just straight numbers. So I'm going to go into my calculator. Let's clear out what we were last working on. And I'll enter in the left side of the equation, which says, and do it exactly as the original, just in case we made a mistake when we were rearranging it. So 2 log x minus, and then I'll do log of x plus 2. So x plus 2. Okay, press enter. And then down here, I'm going to enter in the other side of my equation, which is log of 2x minus 3. Okay, now let's check the solution that we know is the correct solution, which was 2. But I also want to show you what the other solution would look like. So back over here, I'm going to show you y -3. Just in case you didn't catch it, you would catch it on the check in the calculator. So let's try 2 and -3. So start my table, second window, started at 2, go into my table, second graph, and you can see y1 equals y2. So we've done that correctly. Now we can start the table again at -3, but it's not far to go. And you can see for -3, error for both. Even if there was just an error for one of them, it doesn't satisfy the equation. So I know for sure that the only solution is x equal to 2.